Tonight, imagine standing in total darkness, the air thick with anticipation, and then suddenly, a low mechanical growl breaks the silence. Not loud, not aggressive, just powerful. A sleek silhouette rolls forward. And then, without warning, a burst of fire erupts from the rear like a dragon awakening. This is not science fiction. This is not a Hollywood prop. This is the mind of Maxwell Chikumbutso at work. For years, Maxwell has been known for bold, unconventional engineering claims, machines that challenge the boundaries of traditional science. But this creation, this machine that literally breathes fire, might be his most theatrical, most controversial, and most unforgettable build yet. At first glance, the car looks like something from the future. The body is sculpted, aerodynamic, low to the ground. Its sharp LED strips slice through the night like blades. The paint reflects light in metallic waves. It feels alive even before the engine starts. Then comes the ignition. The power system hums, not a chaotic roar, but a controlled mechanical symphony. Maxwell's design philosophy has always leaned toward energy independence and unconventional propulsion concepts. And while critics debate the science, one thing cannot be denied. He understands spectacle. As the vehicle accelerates, something extraordinary happens. From the rear exhaust ports, carefully engineered flame channels, controlled bursts of fire shoot outward. Not random explosions. Not reckless backfires. Precise, timed, visually stunning fire jets. The flames don't just appear. They dance. Each burst is synchronized with throttle response. A tap, a flicker. A hard press, a blazing plume. In the darkness, it looks like the car is breathing. Why build a flame-shooting car? Because innovation is not always about practicality. Sometimes it's about statement, about rewriting expectations, about making the world look twice. In the automotive world, we've seen extreme machines before. Brands like Lamborghini and Bugatti build cars that push speed to unimaginable limits. Hypercars chase aerodynamics, horsepower, and top speed records. But Maxwell's approach is different. He builds conversation. This machine blends performance art with engineering. The flame system, reportedly integrated through a controlled fuel injection modulation setup, channels excess combustion gases into reinforced titanium exhaust chambers. Ignition nodes at the tips create visible flame bursts under specific throttle mapping conditions. It's theatrical engineering, but engineered nonetheless. And as the car rolls through an open test ground at night, cameras capturing every angle, the fire reflects off the pavement like molten light. The crowd stands back, phones raised, faces glowing orange from the heat of the spectacle. But beneath the flames lies something deeper. Maxwell Chikumbutso has long positioned himself as a symbol of African technological ambition. In a world where innovation headlines often emerge from Silicon Valley, Germany, or Japan, he insists that groundbreaking engineering can rise from Zimbabwe. And that symbolism matters. The flame-shooting car becomes more than a machine. It becomes a message. A message that creativity is not geographically limited. A message that bold ideas do not need permission. A message that engineering can be dramatic, daring, and disruptive. Of course, controversy follows closely behind. Engineers question feasibility. Analysts demand independent verification. Social media divides into believers and skeptics. But the spectacle continues. The car doesn't just shoot flames while stationary. As it accelerates down a closed strip, the fire trails briefly behind it, creating the illusion of a comet tearing through the night. The exhaust crackles. The air vibrates. The heat distortion bends the camera lens. Inside the cabin, the design is equally futuristic. Digital clusters glow softly. Minimalist controls dominate the dashboard. Ambient lighting pulses, in sync with throttle input. The steering wheel feels like something pulled from a prototype racing lab. And when the driver presses harder, another eruption. Longer, brighter, louder. The fire surges outward in a controlled arc, momentarily turning night into day. But here's where the story becomes even more fascinating. Because this isn't simply about flames. It's about identity. Maxwell understands modern media. In the age of viral clips and 10-second attention spans, visibility is power. A flame-shooting car is impossible to ignore. It spreads across platforms instantly. Debate fuels engagement. Engagement fuels awareness. And awareness fuels legacy. Yet behind closed doors, development wasn't simple. Reinforced exhaust systems had to withstand extreme heat stress. Fuel delivery timing required microsecond calibration. Safety shielding was integrated to prevent structural damage. This wasn't just attaching a flame kit to a sports car. This was engineered theater. And as testing continued, the vehicle evolved. The flame bursts became cleaner, more symmetrical, more dramatic. Night demonstrations turned into carefully choreographed showcases. Imagine a wide runway. Total darkness. The car sits still. 3 seconds of silence. Then ignition. A slow roll forward. A pause. And then twin pillars of fire erupt simultaneously from both sides of the rear exhaust. Symmetrical, powerful, cinematic. The crowd gasps. Cameras shake. Somewhere in that moment, whether you believe every engineering claim or not, you realize something undeniable. You are watching someone refuse to build ordinary machines. You are watching ambition made visible. But the real question is, what comes next? Because if Maxwell can engineer controlled fire displays into a road machine, what other boundaries is he willing to test? Will future versions integrate adaptive flame patterns? Could performance mapping create different fire signatures for different drive modes? Will this machine remain a one-off spectacle or become part of a limited production run? The fire fades. The engine idles. Heat rises into the night air. And the silhouette remains, still, confident, unapologetic. But this is only the beginning. Because behind the scenes, new prototypes are already taking shape. Rumors suggest enhanced propulsion concepts, lightweight composite frames, energy systems that challenge conventional fuel dependency models. And if the fire-breathing car was designed to capture attention, then the next machine may be designed to capture history. Some inventions aim to be practical, some aim to be profitable, and some aim to be unforgettable. This one chose unforgettable. Yet as the smoke clears and the glow disappears into darkness, one thing becomes certain. The flames were never just about fire. And presence, once established, begins to evolve. Because what most people don't see is the laboratory phase after the spectacle. The quiet hours, the redesigns, the recalibrations, the relentless pursuit of refinement. In a private testing facility, long after the cameras are gone, the fire-breathing machine returns to the lift platform. Engineers gather around thermal monitors. Heat signatures glow across diagnostic screens. The titanium exhaust housings show stress patterns, not failures, but lessons. Maxwell studies the data carefully. For him, the flames are not chaos. They are controlled combustion art. Every burst is mapped. Every ignition sequence measured. Flame length, color temperature, exhaust velocity, all variables tracked, adjusted, optimized. Because version 1 was proof of concept. Version 2 is precision. And precision changes everything. Imagine a redesigned system where the flame isn't just expelled from the rear, but subtly redirected through multi-vent channels integrated into the diffuser. Not dangerous. Not uncontrolled. But visually dramatic, like wings of fire expanding briefly before vanishing. Now imagine drive modes. Stealth mode, no flames, silent performance. Sport mode, short aggressive bursts. Dragon mode, extended synchronized twin plumes under heavy acceleration. The software begins to feel almost cinematic. A performance choreography system embedded inside the vehicle's ECU. Not just transportation, but theatrical mobility. Critics will still question it. They always do. Some call it unnecessary. Some call it exaggerated. Some call it impossible. But history has always treated bold engineers the same way. First doubt, then debate, then recognition. And whether you see this machine as revolutionary engineering or dramatic expression, one reality remains. It commands attention on a global scale. Now picture an international auto showcase. Dim lights, massive LED screens, a silent stage. A narrator's voice echoes through the hall. A countdown begins. 5, 4, 3. Suddenly the rear of the car ignites in a synchronized flame arc. Not wild, not reckless, but shaped like controlled jets, forming a temporary halo of fire behind the vehicle. Gasps fill the room. And in that moment, Maxwell doesn't just present a car. He presents a statement. Africa is not waiting to be invited into the future. It is building its own version of it. But beyond spectacle, a deeper ambition starts forming. What if the flame system isn't just visual? What if future models use thermal energy recapture, redirecting excess combustion heat into auxiliary power modules? What if dramatic aesthetics evolve into functional hybrid heat recovery systems? Now the conversation shifts, because suddenly the fire is no longer only symbolic. It becomes experimental. Energy reclamation, advanced combustion control, exhaust plasma studies. The line between performance art and experimental propulsion begins to blur. Late-night development sessions stretch into early morning. Whiteboards fill with sketches. Carbon fiber panels are stripped and reshaped. Aerodynamic flow simulations test how flame bursts interact with rear downforce patterns. Because even spectacle must obey physics. And Maxwell understands that to remain credible, the machine must not just look powerful, it must perform powerfully. Acceleration tests begin. 0 to 60 benchmarks. Quarter-mile evaluations. Thermal durability runs. The flames return during high-speed passes, not constant, but punctuated. Intentional, like a heartbeat under pressure. And the internet erupts again. Clips circulate globally. Millions watch in disbelief. Some convinced it's staged. Others convinced they are witnessing the beginning of a new performance niche. Flame-integrated performance vehicles. It sounds outrageous, until it becomes real. But here's where things get even more intriguing. Because internally, there are whispers of an even more ambitious concept, a next-generation chassis designed specifically around thermal expression. Not adapting flames to a car, but designing a car around controlled fire. Reinforced ceramic exhaust vanes embedded into the body. Heat-resistant nanocoatings. Active cooling ducts that glow subtly under extreme output. Not just a car that breathes fire. A car that visually communicates power through temperature. Imagine nighttime highway footage. The machine accelerates. The rear diffuser glows faintly amber before twin streams ignite briefly, clean, symmetrical, almost ritualistic. The fire fades instantly, leaving only the echo of combustion and a streak of awe. And in that silence afterward, the most powerful realization settles in. The world may debate the science. The experts may argue feasibility. The skeptics may demand proof. But no one can ignore the image. And sometimes in the modern era, image is ignition. Yet Maxwell isn't slowing down. Because the fire-breathing machine was never the destination. It was the spark. Behind closed doors, new materials are being tested. Lighter alloys. More heat-tolerant composites. More advanced control modules. The vision expands beyond spectacle into identity branding. Vehicles that don't just move through space, but leave emotional impact behind. Imagine future cities where electric silence dominates the streets and then one machine passes. Not noisy, not chaotic, but visually unforgettable. A brief flare, a controlled blaze, a signature. And suddenly the question isn't, why build a car that shoots flames? The question becomes, why build anything ordinary at all? Because once you prove you can command fire, what else becomes possible? And as the prototype idles under the dim workshop lights, faint heat waves rising into the air, Maxwell stands beside the machine, not celebrating, not explaining, just observing. The flames may be temporary. That ambition begins to stretch beyond metal, beyond combustion, beyond even the vehicle itself. Because once a machine becomes a symbol, it stops being just engineering. It becomes narrative. It becomes movement. Inside the workshop, discussions shift from how high can the flames go to how far can the idea travel. Maxwell studies global automotive trends, the rapid electrification movement, autonomous systems, artificial intelligence integration, lightweight architecture revolutions. The world is chasing silence, efficiency, digital control. So, what happens when you introduce controlled fire into an era obsessed with quiet minimalism? You create contrast, and contrast creates memorability. The next prototype doesn't just focus on flame intensity. It focuses on flame intelligence. Sensors begin monitoring ambient light conditions. The car calculates visibility range before allowing ignition sequences. Wind speed adjustments refine plume shape. Even altitude becomes a factor in combustion tuning. Now the flames are adaptive, not just dramatic, responsive. The vehicle becomes aware of its environment. It knows when to remain restrained. It knows when to unleash visual power. The software evolves into a guardian of spectacle. And internally, another layer of development begins. Materials scientists experiment with high-temperature ceramic mesh inserts that shape the flame into patterns. Not random bursts, geometric signatures. Imagine acceleration triggering a brief V-shaped flame formation, or dual spirals under extreme throttle pressure. Not chaos. Design. Because when art meets engineering, spectacle becomes architecture. Testing intensifies. Closed runway. Demonstrations expand into endurance trials. Continuous high-load acceleration. Heat dissipation monitoring. Structural integrity scans after repeated ignition cycles. The goal is no longer to impress once. The goal is to endure. And endurance builds legitimacy. Meanwhile, public curiosity grows louder. Forums debate whether this is performance modification or entirely new automotive category. Analysts speculate about regulatory implications. Safety boards question compliance frameworks. But innovation has always outrun regulation. History proves that. From turbochargers to hybrid drivetrains, breakthrough ideas initially felt extreme, unnecessary, even dangerous, until they became standard. And while the flame-breathing car may never become a mass-market commuter vehicle, it could define an era of experimental automotive expression, a period where vehicles weren't just tools of transport, but statements of imagination. Inside the design studio, sketches of future evolutions line the walls. A track-only edition with extended flame projection capability for controlled exhibition events. A limited Founders Series model with engraved exhaust chambers and serialized ignition mapping. Even a conceptual autonomous showcase version. Imagine a driverless vehicle performing choreographed acceleration bursts, flames synchronized to music during controlled demonstrations. The line between automobile and performance stage dissolves. But beneath all the ambition, Maxwell remains focused on one core principle: control. Fire without control is destruction. Fire with control is power. And that distinction defines the machine. Advanced shielding layers prevent heat transfer to critical components. Real-time diagnostics shut down ignition instantly if parameters exceed safe thresholds. Multi-stage ignition timing ensures flame bursts remain momentary, precise, calculated. Nothing is accidental. Nothing is reckless. Because true innovation balances daring with discipline. And as weeks turn into months, the machine matures. Its ignition note sharpens. Its throttle mapping smooths. The flame bursts become cleaner, almost sculpted. Night testing becomes ritual. Dark runway. Still air. Headlights piercing forward. The car rolls slowly at first, almost respectfully. Then acceleration. Twin streaks of fire ignite in perfect synchronization, extending outward before dissolving into glowing embers. Heat shimmers against the asphalt. And for a brief second, the machine looks less like a car and more like a myth. A mechanical dragon, restrained by mathematics. But evolution never stops. Conversations begin around hybridizing the spectacle with sustainable fuel blends. Could biosynthetic fuels produce cleaner flame signatures? Could future versions integrate alternative combustion mediums that reduce emissions while maintaining visual intensity? The ambition widens again. Because if the world questions sustainability, the answer may not be to retreat from boldness, but to innovate within it. Engineers simulate new injector geometries, micro-nozzle arrays capable of shaping flame density, thermal recycling ducts that capture residual heat energy and redirect it into auxiliary battery charging systems. Now the fire isn't just leaving the car, it's feeding it. The prototype enters a new phase, a balance between aggression and refinement. Acceleration runs grow faster. Cooling cycles grow shorter. Ignition sequences grow sharper. And the world keeps watching. Some still doubt. Some still debate. But everyone remembers. Because once you've seen a car breathe controlled fire under a night sky, ordinary exhaust notes feel different. Ordinary acceleration feels quieter. Ordinary machines feel tame. And maybe that was the real objective all along. Not to normalize flames, but to redefine expectation. Because once imagination crosses a line like this, it rarely returns to safe territory. Inside the facility, another chassis waits under a dark cover. Lighter, whiter, lower. Its exhaust architecture redesigned from the ground up. Not adapted for flames. Engineered for them. The cover slowly lifts. Metal glints under the lights. Cooling ducts carved like veins along the body. Rear vents positioned with surgical precision. This is not iteration. This is escalation. And as Maxwell walks around the new frame, silent, focused, calculating, one thought becomes unavoidable. The first fire-breathing car was proof. The second will be legacy. Commands it not as a trick, not as a stunt, but as a language. Because by now, the fire is no longer an attachment to the vehicle. It is part of its vocabulary. A new dialect in the conversation between machine and motion. The third blueprint evolves beyond traditional combustion theatrics. Engineers begin mapping flame output to telemetry feedback, acceleration angle, tire grip, torque distribution, all feeding into a dynamic ignition algorithm. The car doesn't just respond to the driver anymore. It anticipates. If rear traction slips slightly under high torque, flame bursts shorten automatically to preserve balance. If aerodynamic load increases at higher speeds, the ignition system compensates to prevent airflow disruption. The spectacle bends to physics in real time. Now the machine is thinking. Not conscious, but calculated. And with each new revision, the distance between engineering experiment and automotive philosophy grows smaller. In a dimly lit simulation room, holographic airflow models rotate in midair. Engineers analyze how flame projection interacts with rear diffusers at 120 miles per hour. Heat plumes ripple digitally across virtual wind tunnels. Adjustments are made before metal is ever cut. Because in this phase, imagination is filtered through mathematics. The fourth prototype begins with a radical idea: modular flame channels. Interchangeable exhaust architecture allowing different visual signatures depending on the event. Exhibition mode, track mode, private test mode. Each configuration locked behind safety authentication systems. Because control remains sacred. Outside the workshop, whispers spread further. Automotive journalists request demonstrations. Investors express curiosity. The critics sharpen their skepticism. And Maxwell? He remains quiet, because the machine speaks loud enough. One evening, under controlled conditions, a closed-air field demonstration is arranged. No grand marketing campaign. No dramatic announcement. Just a select group of observers standing at a safe distance. The car rolls forward slowly. No flames. Just presence. The air feels tense, like a storm waiting to break. Then the driver switches modes. The rear diffuser glows faintly, ceramic channels warming gradually. Not sudden. Not explosive. Intentional. Acceleration begins. At mid-throttle, twin narrow jets extend briefly, clean and symmetrical. At full throttle, something new happens. Instead of a simple burst, the flames arc outward in a wider controlled spread, forming a temporary crown of fire before retracting instantly. Not longer, not reckless, but more refined than ever before. A collective silence follows. Because refinement is more intimidating than chaos. Back inside the lab, discussions turn philosophical. What is the purpose of fire in a modern vehicle? Is it rebellion against electric silence? Is it artistic resistance to uniform design? Or is it simply proof that imagination still outruns expectation? The team begins exploring how thermal aesthetics could merge with emerging propulsion systems. Experimental hydrogen combustion mapping. Plasma ignition studies. Advanced heat-resistant composites that glow subtly without active flames. What if future iterations don't even need traditional fuel bursts to create visible fire signatures? What if controlled energy discharge can simulate flame-like visuals through plasma arcs, cleaner, safer, equally dramatic? Now, the horizon shifts again, because the concept of fire breathing evolves beyond literal combustion into visualized energy expression. The machine becomes less about burning fuel and more about displaying power. And power, when displayed with discipline, becomes identity. The chassis under development grows more aggressive. Wider stance. Active aero flaps. Thermal-reactive paint that subtly shifts hue under extreme heat exposure. At night, after high-performance runs, the body panels faintly shimmer, evidence of energy coursing through its structure. No decals. No exaggerated branding. Just presence. And somewhere during these long nights of redesign and recalibration, a realization settles over the entire project. The flames were never the peak. They were the doorway. Because once you prove you can control one of nature's most destructive forces in measured bursts from a machine, you unlock a different mindset. Limitations feel negotiable. Rules feel flexible. Possibilities feel expandable. And in the quietest corner of the facility, Maxwell studies a digital rendering of what may become the boldest evolution yet, a fully re-engineered platform where exhaust architecture is embedded into the structural spine of the vehicle. Heat channels integrated into load-bearing components. Thermal distribution engineered into the frame itself. Not an add-on. Not an afterthought. An ecosystem. Outside, the world continues debating. Inside, the work continues refining. Because innovation doesn't end when the crowd stops cheering. It deepens. The fifth concept sketch appears on the screen. Lower roofline, sharper rear taper, flame ports angled with aerodynamic precision. Every millimeter intentional. Every curve designed to harmonize with controlled ignition. If built, it won't simply shoot flames. It will sculpt them. And as the digital model rotates slowly in silence, one final thought echoes through the workshop. When history looks back at the era of silent electric revolutions and autonomous transport, there will be a chapter about the machine that refused to whisper, the machine that chose to roar in light. And the story? And one day, the workshop lights will dim for the final time. The tools will be set down. The simulations will freeze on their last render. The prototype will rest, not unfinished, but complete in its evolution. The final version rolls out not with chaos, not with noise, but with certainty. Its stance is lower than ever before. Its body sharper. Its lines cleaner. Every vent, every panel, every ceramic-lined exhaust channel integrated with purpose. There are no exaggerated gestures anymore. No need to prove anything. Because now the machine knows exactly what it is. The runway is empty. Night surrounds it. No crowd. No cameras. Just open space. The engine hums to life, controlled, confident. The car begins to move, slowly at first, like a predator testing the air. The rear diffuser glows faintly, heat building in disciplined silence. Then acceleration. Not reckless. Not desperate. Deliberate. At half throttle, twin streams of flame extend briefly, sharp and symmetrical, then disappear. At full throttle, the ignition sequence activates one final time. The flames surge outward in a perfectly sculpted arc, brighter and cleaner than ever before. Not wild, not chaotic. A crown of controlled fire rising against the night sky, powerful, precise, unforgettable. And then silence. The fire retracts instantly. The engine settles into a calm idle. Heat shimmers above the asphalt before fading into darkness. In that stillness, the meaning becomes clear. This was never about destruction. Never about shock alone. Never about noise. It was about mastery. Mastery over combustion. Mastery over spectacle. Mastery over doubt. A car that breathes fire sounds like fantasy. But what truly matters isn't the flame itself. It's the mindset required to build it. The refusal to stay within safe lines. The willingness to risk criticism in pursuit of something unforgettable. Whether history labels it controversial, theatrical, or visionary, it cannot label it ordinary. Because ordinary machines don't rewrite expectations. Ordinary machines don't force conversations across continents. Ordinary machines don't make the night sky glow. As the car slowly rolls back into the shadows of the facility, one truth lingers long after the flames have vanished. Innovation is not always quiet. Progress is not always subtle. And sometimes the future doesn't whisper.